Great. So I'm going to cover a couple of specific things for our database, which is part of the Mapping Archaeological Heritage in South Asia project. So I try not to recover what Stefania has already said. One thing to point out, and I know what we've talked about in this workshop session here are very specific heritage, site management, sort of large scale projects, but it's worth pointing out, and this is because these are the projects that we have the funding. Arcadia's funding 10 different projects globally. Historic England is creating the historic environment records, but the Arches project itself is, as Jack mentioned, also developing Arches for science to cope with and manage science data on a less heritage scale. And the collections arches as well. So we're giving very specific sort of historic environment examples, but if you're interested, this is the nuts and bolts of how you can build it, but there are different instances and different things that arches can do. So it's been an interesting journey for us within our project, with and how we've sort of learned and grown and actually fed into the development of the software. So our project is based in India and Pakistan. The area that the MAHSA project covers is the Indus River Basin and surrounding areas, a Ganges Basin, and that includes also a phase. In our current phase, we're looking at coastline heritage, with the potential as well to record maritime heritage, and that's something we'll be looking at in the next few years. We are also funded by Arcadia, and for some reason the clicker has decided it's not working. Okay, great. Okay, so the MAHSA project, we have various different information sources that we're using to build our database. Our remit is the same as the MAHSA project, which is documenting endangered archaeological heritage. The primary risks in South Asian context come from development, both for agriculture and urban expansion, but there's also a huge risk from climate change, not least flooding, and the recent devastating floods have shown the urgency not only for risk to human life, but also the archaeological heritage, which are often quite intertwined, because often it's the old river courses which will actually flood. So there's quite a close relationship between where people were living in the past and the danger at the moment to where the flooding events will happen. So for our project, we're using different data sources. One of the historical maps which were produced by the British Empire in the late 19th and early 20th centuries. And these maps were produced on a scale of 1 inch to 1 mile, so incredibly detailed scale. And copies of these were deposited within the UK deposit libraries, the copyright library. So that includes the British Library, Cambridge University Library, the Bodleian Library, and the National Library of Scotland. The British Library has a huge, the largest collection of these maps, and we've been digitising these because they actually contain a lot of archaeological information, most of it recorded incidentally as features on the landscape, which we're now recognising as, in many cases, undocumented archaeological sites, or sites which may have been documented but have subsequently been destroyed. We're also using remote sensing imagery data. So we have satellite imagery, for example, Landsat. We also are starting to explore using the declassified American spy imagery, so Corona and Hexagon imagery. And then, of course, we have legacy data. So that's the published archaeological surveys. There have been many hundreds of archaeological surveys that have been produced over the years. So we have thousands of records that have already been published, which may be published, mostly published in paper, with coordinates sometimes recorded before the use of GPS. So we have many, many legacy data records which have a location that perhaps needs some correction to pop it into its geolocate it on the map using the satellite imagery. So to get to an accurate data set and a rich and enriched data set, we are digitizing the historic map sheets and georeferencing them. To date, we've we've scanned over 2,000 map sheets. We've georeferenced over 1,400 of those. We have a standard georeferencing protocol to ensure that everything we're doing is replicable. We are looking at the map features, and we're looking at particularly mound features. So these are essentially tell sites in the landscape. And we are using the georeference maps to extract those mound features. We've created a machine learning algorithm that helps speed up this work, so that it automatically extracts those features from the maps. And then we cross-reference those with published legacy data and the satellite imagery to pull together all the information that we can about these potential sites and archaeological sites. So the result is that we then have multiple data sets that we can see the different, so we have the historical map, we look at the satellite image, and in many cases, you can see the threat to the site that's happening really rapidly. So in some cases, so you can see here a site which has been extracted automatically through machine learning. We've then gone with our team of research assistants to check this on the satellite imagery. And here you can see there is the mound site, and it's starting to be chopped up and chopped into and leveled in order to create fields. And sometimes just using Google Earth time slider, you can see within a few years, the site gets chopped and chopped and chopped until it's completely leveled and invisible on the satellite imagery. We're also developing an algorithm to classify and identify land use change as well. So this is something we're trying to develop that will classify when we've got encroachment or threats to archaeological heritage. And then, of course, ground truthing being a really important part of what we're doing in the project. So actually going into the field, verifying whether the sites we think we have are actually archaeological. Of the sites that we already know, what condition are they in, what are the current threats? So all of these threads are coming together. And then the point of management and information dissemination is the Arches database that we're building. So you've heard us talk about resource models, and essentially this is Arches terminology for what you understand usually as the tables within a database, how you're breaking up your information about the record. So we have, these are the different resource models that we have within our database. So we're recording activities, what were people doing and where, what kind of field work. We have the heritage location, so what you'd imagine as the actual site itself. And then this concept of a heritage area. So if we have, for example, 3 different mounds within a landscape, and we think that these are related, we understand from the archaeology that they're related, we can define that as an archaeological landscape. We have historic maps, and I've talked about those, the map sheets themselves, and I'll show a worked example of what we're doing with those in terms of releasing data and making that available. So we've created a specific resource model to capture the information about historic maps, because not only do they have interesting information on them, they are themselves an historical record. And actually we found some really fascinating information about the people, the surveyors who were making the map sheets, who actually were skilled South Asian surveyors who then got written out of the subsequent colonial history. So we're actually finding there's way more to just the dots on the maps. The maps themselves are giving us a really rich record about the construction of the archaeological knowledge as well, and how we've got to this information today. The information resource, so that's things like publications, different forms of satellite imagery, for example, so we can record where we're getting information from. The person organisation, so who's actually done the work, so we have an audit trail, who went and visited this site, who georeferenced this map, and that's partly for auditing and understanding, you know, if there's a mistake, it's quite useful to say, oh, you can actually talk to this person, or you can go back and look at original publication. But it's also, you know, crediting work as well. So it could be that we have one person who's done a few map sheets, but if they want their work credited, they can be recorded here, and that just stays as part of the record. And then the remotely detected features. So that's, it includes things like the satellite imagery, but also the historic maps. And we have that as a separate resource model. I'll talk about that in a minute, how we're working with it. And here's the lovely, pretty starburst, but this essentially shows how all of different features can relate to each other. So in the middle, we've got an historic map. All the purple dots are mound features we've identified off it. And then the green dots are people who are related to it. So who georeferenced the map, who was the surveyor at the time of making the map 100 years ago. So you can see that eventually you can actually graph and show all of those relationships within the database. And this is just an example. This is our heritage location, so you can see the details of all the different types of information that we're storing within each of our resource models. So we have really the potential to have incredibly rich records. So the machine learning that we're conducting, we have this machine learning algorithm which will automatically draw around these shapefiles, draw shapefiles for us, and then as humans we can use that to speed up our work, but then go and make an assessment using the satellite imagery, using the publications as well. And we've got a publication if anyone's interested in reading about that work and the algorithm, which is itself open source and available for you to download and have a look at. So we have these remotely detected features. They're recorded as such because we don't know that they're archaeology, and they sit in a separate resource model. Once they've been verified, we move them into our heritage location model. So we felt it was important to have that distinction. So we're being very clear about what is and isn't confirmed archaeology. For the historic map, so if you go to our database at the moment, the information we have publicly available is all about these historic maps. So each one of these little grid squares is a paper historic map sheet that's been scanned and georeferenced. And we've transcribed all the metadata that's written around and on the map sheets. And you can go and browse all of that metadata. We're then using the IIIF, so this is the International Image Interoperability Framework, which is embedded within Arches and allows us to then have a viewer which links. This is actually the Cambridge University Library IIIF viewer. So from Arches, we have this linked open data. You can click through and actually pull up the historic map image. But that image is being hosted by Cambridge University Library or by the British Library. So the idea is that we can be the geospatial search portal, but it's the libraries themselves who continue to host the images and make them available. And this is, again, one of the power of what we're doing with Arches and having that interoperability. You know, we don't have to do everything, but we can point to the people who are doing it. And Stefania mentioned the internationalization. So we currently have an interface working in Urdu. You can see that we had to translate 11.6 thousand terms in order to do this. And so there is no limit to the number of languages. In theory, you can have Arches operating in, but you will need to translate all of these terms. And these are just the terms for the interface. So we also plan to work to translate all of our vocabulary terms as well. But it's an eminently doable activity. You just need to put the time into it. But once you have it, then you have a fully functioning Arches, which is quite happy working with a script that reads from right to left, which is really wonderful for our end users and how we hope to use it. So that's a real fly through of some specifics, and just to acknowledge all of the partners that we have within our project and people who've made this possible. But we're happy to answer any questions, and we can show you the examples as well.